Hi, guys. Today we're going to be looking at just an extension of what we talked about with Mr. Jordan last time about graphing linear inequalities. Today we're going to be looking at systems of linear inequalities. So if you'll remember before break, we talked about how a system of equations is just when we look at more than one equation at the same time and look for the answer that answers all of those equations. Same thing with system of inequalities. We're going to look at more than one inequality at the same time and look at what points satisfy all of those. So our goals for today are to be able to graph a system of inequalities and from that determine where the solutions are. And then just the vice versa of that, be able to look at a graph of linear inequalities and be able to write the system of linear inequalities from that. So first problem says y is greater than x minus 2 and y is less than or equal to negative x plus 1. So first things first, when we go to graph, we're going to make sure we have our x and our y axes drawn there. Then we're going to look at our two equations, or inequalities in this case, and determine if they are ready to graph. And both of them look like they are in slope-intercept form. So we're ready just to begin graphing. So starting at the first graph, I'm going to look at it, and it says y is greater than x minus 2. So that tells me the y-intercept is at negative 2. And it tells me the slope, well, since I don't see a number in front of that, it's a 1. And then I always put it over 1 if it's not a fraction. So that's telling me to rise 1, run 1, rise 1, run 1, and go from there. So I'm ready now to connect this. And if you'll remember from last time, we have to ask ourselves one more question before we connect. Should this be a solid line or a dashed line? And in this case, because there is no equal sign, this should be a dashed line. So I'm going to make that dashed line all the way through. All right, last thing we have to do before we move on is we have to talk about shading. In this one, it says that y's are greater than x minus 2. So if I look at my line and I look at where it crosses the y-axis, greater than negative 2 would be on this side of the line. So I'm going to shade this side of the line as being all of the solutions, all of the ordered pair points that satisfy that first inequality. All right, finally ready for the second one. So this one says y is less than or equal to negative x plus 1. So it's also ready to graph. So I begin this one at a positive 1. The slope, there is not a number there in front, there is a negative. So that tells me down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Before I connect these points, I need to determine is it a solid or a dashed. And because I do see that equal sign underneath, that means this time I have a nice solid line coming down through. And then finally, I have to determine the shading. And so again, I look where it says y's are less than or equal to positive 1. So I look at the 1 on the y-axis, and less than is down here on this side. So I'm shading this side of the line. So where do I find my solutions? My solutions occur right here where the shadings overlap. And I can pick any one of those ordered pairs. Couple things that I want to remind myself is I could pick ordered pairs on this line. I could not pick ordered pairs along this line because that line is dashed, this line is solid. But I could pick any of these ordered pairs over here in the shaded region, and that would be a solution to the system. The reason we just answer these with a graph is because there are so many answers here that we couldn't list them all, but the graph shows us a visual of where those answers are. All right, I'm going to move myself over here so that we can see the next problem. All right, this one says, what are the solutions to the system for y is greater than or equal to negative x plus 2 and y is less than negative x minus 2? So in this case, I'm going to start. They both look like they're ready to graph. So in this case, well, I guess I better get my x and my y axis drawn here. Okay, so I'm going to begin at positive 2. And then it says negative x, so that's a negative 1 over 1, which means I'm going down 1 to the right 1, down 1 to the right 1. Before I connect those, I'm going to take a look at my symbol, and my symbol is a greater than or equal to, so that means I'm going to have a nice solid line here in my drawing. Sorry, my line's not very straight there. And then finally, I'm going to look at shading, and this one says I want y's that are greater than or equal to this boundary, or greater than or equal to that negative or that positive 2, so that it becomes greater than on this side of my line. All right, second one. This one says y's are less than negative x minus 2, and so this one's starting at negative 2. It also has a slope of negative x, or negative 1 over 1. So down 1 over 1, down 1 over 1. This time when I look at it, there is not an equal to sign, so that means it's going to be that means I'm going to just have a dashed line here. So I'm going to get my dashed line going. Pen's not wanting to work here. Dashed line all the way. And then finally, I'm ready to shade. This one says I want to shade where y's are less than the line. And so when I look at that line, y's are less than on this side. So I'm going to come shade over here. So again, I'm looking for answers to be where the lines overlap. In this case, the lines don't overlap. So this would be an example of a system with no solution, because there's not a place where those two inequalities overlap. All right, let's try one more together. In this case, we're going to look at the inequality y is greater than 3, and y is greater than or equal to negative 1/2 x plus 1. There we go. Okay, so in this one, the first thing we need to look at is, do we have them both in slope-intercept form? And the answer is yes. However, that top one looks a little strange because it's not completely in slope-intercept form, because we don't see a slope on this problem. And that's because when y's are by themselves, it's one of our special cases, and y by itself, remember, is a horizontal line. So I'm going to come up here to the 3, and I'm going to draw a horizontal line at y equals 3. Now, that says y is greater than, there's no equal to sign there, so it's going to be a dashed line at y is greater than 3. And then finally shading, where our y is greater than 3, they're shaded up above that line. All right, the last one, I'm going to start at positive 1, and it has a slope of negative 1/2, so down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. This one does have the equal sign in greater than or equal to, so this time I am going to have a solid line through those. And then finally my shading. This one says I want y's that are greater than or equal to that line. So where it crosses the y, I look for where they are greater than, and I shade on this portion of the line. So where did the actual answers occur? They occur right up in this area where those shadings overlap. So I could pick any point in this shaded region, and it would be a solution to both of those inequalities. I keep wanting to say equations. All right, so that takes care of the first portion. So really, it's just the same thing that Mr. Jordan talked about last time. It's just we're graphing more than one at the same time, and we're looking for the overlap between those. Our second goal for today was to be able to look at a graph and write the equation from it. So we'll take a look at a few of those. First one here, it says what system of equations is shown by this graph? And so I'm going to start by looking at the red line. And so the first thing I need to look at when I look at that red line is I need to look at where is the y-intercept. So where does this red dashed line cross the y-axis? And it looks like it's right here at point 3. Okay, so if it crosses at 3, that's going to be my y-intercept, positive 3. Then I'm going to start at that point 3 and I'm going to count what's the slope. Looks like I'm going up 2 and over 1. So up 2 over 1 means I have a slope of positive 2 over 1. That's my slope. All right. Finally, I'm going to have the y over here and I need to determine what kind of symbol. So when I look at that line, it looks like I'm shading down below. So that would be a less than symbol. Now, do I need an equal to sign? Nope, not this one because it's a dashed line. It's just y is less than 2x plus 3. I can write it as 2 over 1 or just 2. All right, now let's take a look at the blue line. So blue line, I start by looking at where is my y-intercept. It looks like it's at positive 4. Then from that positive 4, I'm going to count the slope. So it looks like I'm going down 1 and over 1. And so because it's going down 1 and over 1, I'm going to put that negative 1 in front. So negative 1x or negative 1 over 1x. I'm going to have my y out front. And then this time the blue line looks like I'm shading on this side. So that would be a greater than sign. Now, do I need the equal to on this one? The answer is yes. I will need an equal to on this one because, well, my pen again is not wanting to work. Greater than or equal to because it is a solid line on this one. I'll give you a minute to try this one on your own. So guys, on this one, I'm starting with the red line. The red line looks like it's crossing at 2. Did you notice that? The scale on this one is not going by 1, so it's actually crossing at the positive 2. And then to count my slope, it looks like I'm going up 2, 4, 6, and over 2. So 6 over 2, that would be a slope of 3. So 3x plus 2. I'm going to have the y over here on this side, and then looking at that y, it looks like I'm shading on this side, which would be the greater than side. It is solid, so I want the greater than or equal to. All right, now I'm ready to start looking at the blue line. So blue line, I again began by looking at the y-intercept. Looks like it's right here at negative 2. It also has a positive slope, up 2 over 2. So 2 over 2 is 1x. It also looks like I'm shading on this one down below, and so that would be y's that are less than, and because it's a solid line, I would want less than or equal to. All right, one last one. Give this one a try and then check back in with me. Okay, y or the red line first. Looks like it's crossing at 0, so we can say plus 0, and then we're going to look at the slope. Looks like I'm rising 2, 4, and over 2, rising 2, but to the left 2. I'm sorry, rising 4, but to the left 2 would be negative 4 over 2, or 4 over negative 2, which turns out to be a negative 2x. And then my y, I'm looking at that line again. It looks like I'm shading on this side, which would be on the greater than side. And because it's dashed, I'm just going to leave it as a greater than. Finally, looking at the blue line, it looks like it's crossing at negative 2, negative 4. So y-intercept of negative 4. And then counting its slope, looks like it's rising 2 and running 2, 4. 2 over 4, I can write that as 2 over 4. It could also, though, be written simplified as 1/2. So I'm just going to go ahead and change that and make it 1/2. Just simplifying 1/2 x. And then putting my y over here. Looking at this one, it looks like it's being shaded down here below. So that's going to be less than or equal to because we do have a solid line on this one. All right, so guys, I hope that that helps with this one. Really, it's just a putting together of what we did last time and just amplifying it with now more than one system at the same time, more than one inequality. We're going to be talking about this a little bit more in the next couple of days. So go ahead and give your Pearson a try and let us know if you've got any questions. Well, thanks, and we'll see you later.